Why would we have a system that attacks ourselves? Well, it is what it is when you're making electricity, but we have developed a way to process the reactive oxygen species. We make our own antioxidants. One of them, superoxide dismutase. So dismutases take two molecules, reduce one, and oxidize the other, okay? So a gain of electron is a reduction, loss of electron is oxidation. So if you have two reactive oxygen species of superoxide, which is oxygen plus an extra electron, okay, so it's got 3 electrons now instead of 2, and that's a highly reactive molecule. And what I mean by reactive is if you've got oxygen, which normally has 2 electrons spinning against each other, and you add a third, that third electron does not want to be there, and it wants to glom on somewhere, and it'll attack a protein in your cell, it'll attack the lipid biomembrane, or worse, it'll attack your DNA. So you've got this highly reactive superoxide molecule, okay? One of the things we do is we use it with superoxide dismutase. Things in your body to make the superoxide dismutase. So there's 2 of them. There's one on the mitochondrial side, one on the cytoplasmic side. One uses copper and zinc to be formed, one uses manganese, and I'm simplifying this obviously. But you can see how now we're starting to talk about micronutrients, right? What we eat, why it's important, why does it matter? It's not just voodoo, it's not just gobbledygook, but the diet that you put into your system is so important because of this. Without the right micronutrients, you cannot make antioxidants and you will effectively destroy yourself over time. So superoxide dismutase then converts superoxide to peroxide. Well, we all know peroxide is not good for cells, right? So what happens here? Well, this gets then reduced or neutralized by a different antioxidant. And then we've got glutathione peroxidase, okay? You've probably heard me talking about glutathione before. That's one of our most powerful innate antioxidants that we produce. Basically, glutathione is the reduced form, and then you've got glutathione disulfide. You can see GSSG, so 2 sulfide units with a sulfide bridge. And then that uses selenium. This is why you hear about selenium sometimes. And the oxidative form is effectively the antioxidant action. So glutathione will take that unstable electron or 2 electrons, right, spinning around on these free radical species or reactive oxygen species. It'll pull it off, take it into itself, or add an electron to stabilize that, right, and basically neutralize it. So the whole thing about antioxidants is anytime there's an odd number of electrons, it's a reactive thing, and you basically want to pair it up with another electron and make it an even number, okay? And that's how antioxidants work. Glutathione is an awesome one that we make. It's super powerful. And one of the supplements I often recommend and that we have on Well Theory is ALA, which actually provides one of the cysteine molecules needed for your body to make more glutathione. So this is why I keep talking about these antioxidants and these building blocks. Catalase is another one. It takes 2 molecules of H2O2 and it reduces it to 2 waters, H2O, and O2, oxygen. So it's all just chemistry, right? Basic chemistry. But at the end of the day, it's massively important, and it's why we had that slide before with all those diseases.